All right, so what I'm going to do for this video is I am doing a mini review of everything we've talked about of circles for your test tomorrow. Now, how this will work is I did not give you a paper copy of this either in person or on Google Classroom. So, if you want to follow along with me, you're going to have to work them out on your own, or otherwise you can just watch the video and maybe absorb it that way. Okay? This is not for a grade. It's not going to count against you if you don't do it. All this is for is just to prepare you for your test tomorrow. Now, I apologize for what the shaking's getting ready to do because I'm going to try and adjust this where we can see everything. Okay. So what I've done is I've just put one of every kind of problem that you could see on here tomorrow. Okay. I'm going to try and do this kind of slow enough that you get it, but fast enough that this video doesn't take an hour long. So anyway, so first thing we talk about was tangent lines. So we need to determine if this line AB is tangent to the circle. If it's going to be tangent, what's going to happen is where it meets the circle, it's supposed to be a right angle right there. We don't know for sure, but if this is a right angle, that makes this a right triangle, and we can use Pythagorean theorem to see if we can get it. But in this instance, we want to use it in that other format that we talked about. So you start with the bigger side C. So we're going to see if these are equal. We don't know if they're equal yet, but we're going to see. So obviously C is the biggest side, so we let that be 10. The other ones are 6 and 8. And then we type all this in. Hey, look at that. These are equal, which means it is tangent. If they were not equal, we would say not tangent. All right? So now we know they are tangent, and so we still use Pythagorean theorem. So there's our right angle, and so we use Pythagorean theorem again. Notice on this one, we're trying to find the long side, C. So we'll say 12 squared plus 8 squared equals C squared. Oops, I went ahead and did that first. 12 squared plus 8 squared. We end up getting 208. Then we take the square root. And in this instance, I would rather you use the decimal, so just type in the decimal there. So rounding to the 10th, that would be 14.4. Okay. So that's that. Now it says solve for x. So remember when we talked about this, you only worry about the stuff on the outside because those two tangents are supposed to be congruent. If they start from the same point and come and touch the circle, then those two have to be the same. Don't worry about what's in here. Just ignore it. We're only using these two. And then we solve. Get x equals 11. That's all you have to do. Easy peasy. All right. Find the angle measure indicated. Assume that lines which appear to be tangent are tangent. Remember, when the tangent touches the circle, that makes that 90 and makes this 90. So we know two angles are 90. We know one of them is 71. We need to find the other one. Well, remember, this is a four-sided shape. It's actually a quadrilateral, or a kite, but anyway. All quads, when you add up the angles, they equal to 360. And so we will simply subtract the two 90s minus the angle we know. And boom, we get that it's 109 degrees. That's it. Okay, on that problem, guys, that's it. There's no reason you should miss this tomorrow. All right, find the perimeter of the polygon. So we're still using the idea of multiple tangents. So I'm going to try and color code it a little bit. Okay, I'm going to color code who's going to be congruent to who. So this little guy that's marked 10.1, he's going to be congruent with this one. They'd be the same. And then this guy that I'm doing in purple first goes with this one. And then finally this one in blue goes with this one. So let's see what we can do. We know all of this big side is 24.1. We know all the other big sides 25.1. So all we really need is this other one over here. Well, this part of green is 10.1, so I know this part is 10.1. But now I got to find this side marked in purple. Well, to get there, I've got to backtrack all the way here and start, and then work my way around. Okay, how am I going to get this blue? Well, the whole is 24.1, and I'll subtract off the 10.1 that I already know. So the blue is 14. Then what does that make the purple? Well, we'll do the same thing. 25.1, the total, subtract what we know. That makes the purple 11.1. And so remember, perimeter is the distance all the way around. So I'm going to add this one and this one because they already told me that. And then I'm going to add these two little pieces with it. So 25.1 plus 24.1 plus 10.1 plus 11.1. And we end up with a grand total of 70.4. Okay. Now, these next three questions deal with the chords and the arcs. Remember, there's three kinds of problems you could see. There's a problem where you do absolutely no work at all. There's a problem where you might have to do one or two steps. And then there's ones that use Pythagorean theorem. And basically, you just stare at the problem and figure out if you can, and see if you can figure it out really easily or if you're going to need to use Pythagorean theorem. So what I mean by that is, I notice that I have a bunch of these that are marked 4. These are all radii. This piece over here is 2.1, but I don't really need it because look where my x is at. It's right here. That's another radius. So x here is just 4. That's an example where you literally do no work. You have to recognize that that is on a radius, and all the radiuses, radii, are the same length, and so x is 4. Now here, notice where x is at. It's in the center on this big, long segment right here. So x here is the diameter. We need to remember that the diameter is 2 times the radius. So I need to find my radius. I'm going to call that x. X is diameter. So x equals 2r. I need my radius. Well, I noticed that these two together make me a radius. So 8.5 and 7.5 are going to come together. And when you add them together, so add them together and then double it. 2 times 7.5 plus 8.5, and we get 32. Okay, so that was one where you had to do one or two things. Not bad. Now look at this next one. So we've got this little section here is 4.5. A radius is 11.1, and then we know a piece up here. This X right here is on a piece of a chord. And we remember that when a radii touches a chord, it bisects it. So this piece and this piece are the same length. So I'm going to bring the X down. Okay? That is a leg. And so I'm going to use Pythagorean theorem to find it. So x squared plus 4.5 squared equals 11.1 squared. What is 4.5 squared? I don't know that off the top of my head. 20.25. Let me put that here. I don't have enough counter space. $11.1 squared. 123.21. Now I'm going to subtract 20.25. So I get 102.96. Take your square root 102.96. And we'll need to round to the nearest tenth, so we'll say 10.1. There you go. Okay, now we're getting to the angle relationships with circles. And remember, there's three different types. There's inside the circle, on the circle, outside the circle. And every one of those has a different formula that you need to set up. Both of these are inside the circle. And so remember, we said that we set up the angle is 1/2 times arc 1 plus arc 2. So for inside, we're going to set this up. Okay, so this is a numeric example. I look what I'm looking for. That's the angle, so I put X there, and then I fill everybody else in. So the first arc is the 100. The second arc, you come behind it and get 70. Now this one's easy because X is on the left side, everybody else is on the right side. So you can just type that into your calculator. $85. All right. Now we have an equation to do, but it's the same thing because we're inside, so we're still using this form. So the angle is 2x plus 99 equals 1/2 times the arcs. So 148 plus 50. Now remember, to make your life easy, instead of taking half, we're going to double the left side. So So 4x plus, what is 99 times 2? 198. Then you essentially just drop the half. Okay? Let me scoot this up just a little bit. All right, 148 plus 50. We get 198. Subtract 198. 4x equals, uh-oh. Now, don't be freaked out by this, okay? This can happen. You still divide the 4. 0 divided by 4 is 0. Okay? X can be 0, and that's okay. X can be negative, and that's okay. Remember, X is a variable. It's just a placeholder. It's not the actual angle measure. So getting X to be 0 is not a bad thing. Don't freak out. Now, these next two are examples of being on the circle. They both use the same formula. The angle equals 1/2 the arc. Let me put that down here too. So angle equals 1/2 arc. So here's a numeric example. We're trying to find the arc. So 70 is the angle equals 1/2 x. Double the left side. So double 70, you get 140. That's it. This is another on, but it's a different picture. So the angle this time is x. So x equals 1/2 times the arc of 130. Then you type that in. Half of 130 is 65 degrees. Okay. Now here's another on. I think there should be 2 more ons. No, 1 more. Okay. But the same idea even with the equation, okay? So the angle is 7x plus 5, 1/2 times 150. We still double this side. So that would be 14x. I cannot write. 14x plus 10 equals 150. Now we start solving, so subtract 10. And you get x equals 10. Okay? So that is on angles on the circle. Now we're going to look at angles outside the circle. So there's 3 different pictures you could see, but they all kind of look like these 2 birdie shapes right here. Okay? And for both of those, we're going to use this formula. The angle equals 1/2 times the big arc, subtract the small arc. Right? So in this instance, we're trying to find the x, the angle. Big arc's 128, small arc is 48. And this is nice enough that you get to type into the calculator. And so that ends up being 40 degrees. Now, also realize you could have x be one of these 2, in which case instead of typing it on the calculator, you would have to double the left side get all the X's on one side, get everybody else on the other side. It would be a little bit more lengthy of a process, but it's the same idea. You still use the same formula. Here's a equation example of outside. So we take our angle measure 45, set it equal to 1/2 times the big arc 153, subtract the small arc 63x. Now remember, if the small arc has more than one term, you need to put it in parentheses. So it could look like this with more in here. Ours doesn't look like that, so I don't need them here. But just realize you could have that happen to you. All right, so we'll double that. 90 equals 153 minus 63x. Let's make our life easy and just subtract this one. 90 minus 153 gets negative 63 equals negative 63x. And divide by negative 63, so x equals 1. Okay? Now we have segments in a circle. So let me kind of divide this out. Okay, so now we have a segment in a circle. And I still like to color code these. So I like to, let's just say I pick all this line to be one color. And then all of this line to be another color. You essentially just match them up. So the 10 and the negative 5 plus x go together. They're going to be multiplied together. Same thing for the other one. We're going to say 8 times x minus 4 because those are both purple. Now we'll distribute. Let's move the smaller x first. Oops, I can't read. What is that? 18? Divided by 2, x ends up being 9. Okay. Now with outside, it's a little bit different. So we've got this piece that's just outside, and then this longer piece that has an outside part and an inside part. I did that in the same color. Look what I just did. This one's supposed to be green. Okay. Sorry about that. When you have one outside and then one that goes through, we kind of do it this way. The outside piece, you square it, multiply it by itself. And then for the other one, you start with outside times. Now this, what goes in here is the entire segment. So 4 plus x, or I'm going to say x plus 4. So this is outside the whole thing. and we get x equals 5. Now this one has two of these longer ones. So we've got outside, inside green, and then outside, inside blue. So remember, it is always the outside. Look at me, I can't even write. Outside times the whole thing. So I'm going to say x plus 7 plus 10. So notice what I did. The inside the parentheses needs to be the entire length of the segment. So that's going to mean whatever's inside plus whatever's outside. Now I'm going to clean that up a little bit. Then we'll distribute. Let's move to small x. Move the other number. So we get 80 equals 8x. Divide by the 8. And if I did math right, x should be 10. Okay, just make sure I did it right. Okay, now we're getting to the equations of circles, which we talked about today in class. So identify the center and the radius. Remember, the center is h comma k. And so remember, h is right here next to x, k is right here next to y. When you pull them out, change the sign. So that's going to be -8, -5. So the center is -8, -5. Out here at the end is radius squared. I want regular radius. So I need to take the square root of that number and see if I can simplify that or if it's going to be nice and pretty for me. So r is square root of 81 is what number? It's 9. My eraser is awful. There we go. 9. Okay. Again, this last one, guys, that should be super easy. Please don't miss that tomorrow. Okay, now I'm going to give you 3 different sets of information, and you have to write the equation of the circle for me. All right, remember the center of the equation is x minus h all squared plus y minus k all squared equals r squared. Okay, when you have the center and radius, it's really easy. You just plug them in. So x, now it's already negative, so when I plug him in, he needs to be positive. Same thing with that one. Now down here, I have to take this number and square it. So 2 squared is 4. Okay? So when you're plugging them in, you have to change the signs, and then this one, you square it, multiply it by itself. Okay. Now for this one, first thing you do is plug in the center. And then we need to plug this new point in. Now notice when you plug the point in, don't change the sign. Just plug it in as it is. And then all this, we're going to type in. -8 plus 13 all squared plus -3 plus 5 all squared, and we get 29. So r squared is 29. And so now I'm going to rewrite that equation up top. But now that I know what r squared is, I just simply replace it. Okay, now we have the graph. So first thing I would want to do is identify my center and my radius. So it looks like I'm centered right here. That is at 1, 1, 4. My radius is from the center to the edge. Now it looks like 2, but be careful. Look how long this is right here. That's just 1. So the radius is actually 1. Now I write my equation. And down here, 1 squared is just 1. All right. Last thing is to graph the circle. So I always find it best to know the center and radius. So the center looks like it's going to be 3, -1, because you pull them out and change the sign. The radius is going to be 4. That comes from the square root of 16. So I'm going to go put my center, 1, 2, 3, -1. And then in each direction, I'm going to count 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Here we go. 1, 2, 3, 4. 1, 2, 3, 4. Oop. Now I know it's not going to be perfect, but that's not bad if I don't say so myself. Now realize on your test tomorrow, you won't actually be graphing a circle. So what you'll need to do is you'll need to look at each answer choice and see if the center and radius match up. That's what I would do. So from the original, write the center and radius, and then from each picture, write out the center and radius. And if everybody matches, then you pick that answer choice. Okay? All right, that is a quick brush over of everything we've talked about with circles. Now, I made this video because you all asked me to. So I'm expecting to see views on this when I go back and look at it on YouTube. Please use this as a study tool, guys. Okay? I want y'all to do well tomorrow. And while you're studying, as always, if you have questions, please let me know.